Okay, actually, in previous class, we uh, learned about different things like descriptive statistics, inferential statistics. In descriptive statistics, we learn mean, median, mode, and in inferential statistics, we learn population sample, and after that, we learn like percentage, percentile, and 5 number summary. And this topic we already cover. And in this class and today class, I will first write the agenda for this class. That means which topic we are going to uh, uh, learn. After that, maybe tomorrow there will be a class, and I will teach you the hypothesis testing. After that, I guess only one class will be remaining to finish all the statistics. After once we cover the statistics, then we can jump into Python and machine learning algorithm and all the things. And one more thing is, after statistics, I also teach you one class regarding probability, because there are some algorithm like naive Bayes and decision tree, and like this type of algorithm in machine learning, you will find out that there is a huge importance of probability in the future. That's why I will also teach you the probability in maybe after the statistics class, and it will hardly take one class to finish all the things. And you also I will explain like permutation, combination, all the things. And today class, I am writing here. First I will run normal distribution. Normal distribution. Number 2, we will run standard normal distribution. Number 3, we will run like log normal distribution. Number 4, we will run like covariance. Number 5, we will run Pearson correlation coefficient. Correlation, relation coefficient. Number 6, we will run Spearman. That is Pearson and it is Spearman. Spearman's rank correlation coefficient. This topic we will learn today class, and maybe tomorrow class we will learn hypothesis testing. And after, in the case of hypothesis testing, I am written Azure here. Maybe in hypothesis testing, and there is like T test, Z test, there may be ANOVA test, and there is also a chi-square test. This 4 step we will run chi-square test. This 4 test we will run in the next upcoming class, and in today class we will finish this thing, these 6 normal distribution, standard normal distribution, log normal distribution, covariance, Pearson correlation coefficient. After that, Spearman rank correlation, like this. Like all these 6 topics we will cover today class. Maybe tomorrow class we will run hypothesis testing. After running the hypothesis testing, the your statistics class will be over, and after that we will just take a class of probability, and we will run after that Python. Then we will start from normal distribution. I am writing here normal distribution. Normal distribution is also called as Gaussian distribution. Like I am written here also Gaussian distribution. Normal distribution is also called as Gaussian distribution. The curve, like you may see, the curve, that means how the normal distribution or Gaussian distribution is derived. When I teach you the like histogram things, I told you the things like are the histogram, beans, and this thing I already covered to you. And in this I also talked to you that there is a PDF, that means the smoothing of the histogram. Like this also, I run all the things. Here you can see how the normal distribution or Gaussian distribution is formed. There is this type of curve is nothing but called as Gaussian distribution. Then how it is for, I am telling you. Like there is a mean, you can see, I can draw it here. There is a mean, that is nothing but mean. This is called the standard deviation. I told you the previous class, first standard deviation. This is nothing but second standard deviation. This is nothing but called third standard deviation towards left, and this is called nothing but first standard deviation towards right, second standard deviation towards right, and this is nothing but called third standard deviation towards right. Okay, there is in Gaussian distribution. Gaussian distribution is nothing but just smoothing of histogram. That means the histogram we create like this. You can after the creating of the histogram, we just smoothing the histogram. It is nothing but called as the distribution. The Gaussian distribution, or it is also called as the normal distribution. Then how it is for, I will give you the example like weight, height. It always for when you, let's say I will tell you collect the weight of your class. Let maybe 100 students are present in your class, and after the maybe 100 class, let's say you take the weight like your weight like maybe 60 kg, 61 kg, 62 kg, maybe 58 kg, and like this, and after that there may be like 70 kg. When you try to form like a distribution, you may follow like your mean will be this. Your first standard deviation, second standard deviation, third standard deviation to the left, and first, second, third standard deviation to the right. When you form this kind of graph, or you will always see that this always follows this Gaussian distribution. You may ask me that this distribution may be followed like this, or this may be followed like this. Then how I am confident about your weight or height is always follow the Gaussian distribution? It is nothing but called as the log normal distribution. I will teach you in the upcoming hour. That means I will tell you that the weight or height is always following the normal distribution. Then you may ask me that why you are confident about that always follow the normal distribution or the Gaussian distribution. Then I will tell you that one more thing. It is not I am telling, it is told by the domain expert. Who is the domain expert? That means the person who is working like from their past 20 years, and they have a lot of experience on this field. They are told to us that the height and the weight is always followed by the Gaussian distribution. That means your mean is like more. That means in here you may say there are many students weight are following this range. That means I will tell you one more question. There is also called like as empirical formula. Empirical formula. Then what is empirical formula? Empirical formula is nothing but, it is like, let's say this is our distribution. This is our distribution, and I am telling you that this is nothing but mean, and this is first standard deviation, second standard deviation, third standard deviation. This is nothing but first standard deviation, second standard deviation, this is third standard deviation. Then what is empirical formula? Empirical formula tells us that between first standard deviation towards left and between first standard deviation towards right, there are the possibility that 68% of data is falling inside this. Then what is there is also a probability that in second standard deviation 95% of the data are falling, and in third standard deviation 99.7% data will be false. That means it is also called as empirical formula is nothing but 68, 95, 99.7% rule. That means 68% of data will follow in the first standard deviation, 95% data will be followed in second standard deviation, and in third standard deviation there will be like 99.7% data will be followed like this. That means when you correct, like I will told you the example, when you correct the weight of 100 student and you just correct all the things, you will calculate the mean, you will calculate the standard deviation, and you will plot the curve like this. You may see that the 68% of the data is followed always in first standard deviation, and 95% of the data is followed on second standard deviation, and 99.7% data will be followed in third standard deviation. That is nothing but called the empirical formula. And all the things is like Gaussian distribution. These all the terms are related to Gaussian distribution. That means Gaussian distribution, it is like in the middle part there is a more possibility, there are more data are falling in the middle, and in the when you go towards right or when you go towards left, the percentage of data it's coming decrease. That's all about the Gaussian distribution. If anyone has any doubt, you may ask me. After that we can continue. The next step is nothing but standard normal distribution. Then I will tell you the difference between Gaussian distribution and normal distribution and standard normal distribution. Just in first Gaussian distribution or normal distribution, just tell me if anyone has any doubt, you can ask me.
Can you please explain the empirical formula again? I couldn't get that.
Yes, actually it is derived. I am not telling you that it is derived from the domain expert. Domain expert is like the person who is like working on this field like 20 years or 25 years. He has a lot of experience. He's doing this kind of work repeatedly and daily. He's doing this thing and seeing the result, and he just derived a formula that on 68% of the data, that means let's say 100, I will tell you the 100 student, then 68 students weight is follow under first standard deviation, second standard within first standard deviation, and the 95 student weight will follow in second standard deviation. That may just say there is a possibility. I just give you an example. Let's say 60, the weight are 60, 60, 61, 62, 58. Let's say this is like 69. I will calculate the mean. Let's say the mean is like 62. This is nothing but the mean, and I will calculate the mean is nothing but 62. And first standard deviation value, let's say 65, and this is also 65. Let's say this is nothing but 68. Let's say this is nothing but sorry, let's say this is your mean. This is nothing but first standard deviation towards left. That means let's say this value is 60, and this is nothing but 65. This is nothing but 58, and this is let's say 68. This is third standard deviation. Let's say this is 55, and this is let's say 70. Then you may follow that in 60 to 65 this weight, you may follow the 68% of the data may follow inside this first standard deviation, and inside when you see that from 58 to 68 there is like 95% of the data will follow like this. I will just give you example in the hypothetical basis. You may, when you calculate the mean and first standard deviation, second standard deviation, you may follow like this percentage of the data will follow will coincide in this standard deviation, first and second and third. That means 68, 95, 99.7 rule is nothing but 68% of the data will follow inside the first standard deviation. That means from this to this, and 95% of the data will follow like second standard deviation to second standard deviation to the right, and 99.7% data will follow like standard deviation from left to third standard deviation towards the right. Are you got it? Are you got it? I will explain.
Yes, sir.
Okay. Like one more thing I would like to add over here, like this Gaussian distribution is nothing but it is like 0.5% is from left. That means it is symmetrically, when you calculate the mean, it will symmetrically divided towards left and towards right. That means 0.5% will be inside right and 0.5% will be inside left. After that I will tell you the second topic, that is nothing but standard normal distribution. First we run like normal distribution. This is nothing as a standard normal distribution. In standard normal distribution, what we do that, like let's say in normal distribution, our mean is let's say 3, our standard deviation is like 1. This is in normal distribution. We have to convert mu is equal to 0 and standard deviation is 1. That means when we convert any Gaussian distribution to mu is equal to 0 and standard deviation is equal to 1, that is nothing but called as standard normal distribution. That means in any distribution that may be mu equal to 3, or mu may be in that case mu may be like 5, 7 or anything else. And in that case standard deviation may be 5, 7 or 9 or any case. In this case, when we convert the Gaussian distribution to like mu equal to 0 and standard deviation equal to 1, that is nothing but called the standard normal distribution. I will give you an example. Let's say this is a distribution. In this case mu is equal to 3 and standard deviation is equal to 1. Then we convert this distribution like this, and in this case mu equal to 0 and standard deviation equal to 1. This is nothing but called as normal distribution. This is nothing called as standard normal distribution. We will convert. How we will convert? We will convert with the help of z-score. Then you may ask me what is z-score. Then z-score is, there is a formula for z-score. I will tell you why we are converting normal distribution to standard normal distribution. I will tell you. Just give me 5 minutes. I will explain all the things. With the help of z-score, we are converting normal distribution to the standard normal distribution. That means what is our z-score? Z-score formula. Z-score formula is nothing but summation of is equal to 1 to n x minus mu by standard deviation c. Nothing but called as the z-score value. That means I will tell you example, like our value may be x equal to 1, 2, 3, 4, 5. Let's say this is our from normal distribution. We will convert to standard normal distribution. Then what is our value should be? Our value should be summation of I equal to 1 to n x minus mu divided by c. Let's say in this case our mu is nothing but 3. Our standard deviation is nothing but 1. Let's say after that we will convert all the value. Like here we can say our x is equal to 1 minus mu by standard deviation 1. Then second value will be 2 minus 3 by 1, 3 minus 3 by 1, 4 minus 3 by 1, 5 minus 3 by 1. Let's say this value will be minus 2, minus 1, 0, 1, 2. That means we convert using z-score from any distribution like normal Gaussian distribution to standard normal distribution. That means in Gaussian distribution our value is 1, 2, 3, 4, 5, and in standard normal distribution our value will be minus 2, minus 1, 0, 1, 2. In this case you will calculate that mu is equal to nothing but 0 and standard deviation is nothing but 1. That means we will convert any Gaussian distribution by the help of z-score. We will convert to the standard normal distribution. Then there will be a question you may ask me, then why we are converting the normal distribution or Gaussian distribution to the standard normal distribution? We are happy with standard, we are happy with normal distribution, we are happy with Gaussian distribution, we are just smoothing the histogram and calculate or derive the Gaussian distribution. We are happy with that. Then why we are looking for standard normal distribution? Why we are converting mu is equal to 0 and standard deviation equal to 1? And I will tell you one more thing is that let's say I will give you one example. The region why we are converting. You ask me the region of converting or purpose of the converting. Let's say I will give you an example. There is a column like age, there is a column like weight, there is a column like distance. Age is calculated as year, weight is calculated as kg, distance is calculated as, let's say, kilometers. I may tell you the age of let's take 5 record. Let's say age is nothing but 50, 60, 55, 45, let's say 29. The weight, you may ask me, the weight is like 50 kg, 60 kg, 45 kg, let's say 39 kg, let's say 51 kg. The distance, you may tell me 120 km, 130 km, 140 km, 100 km, or let's say 50 km. You may tell me that you may observe one thing is from here that all are numerical or all are numbers, but like 50 in age is fully different from the like 15 kg. That means 50 years, that is nothing but there is a other properties, and 50 kg is nothing but you may not tell you that you cannot tell you that 50 year is equal to 50 kg or equal to 50 kilometer. That means all the properties, all the derived formula is far different. Although the number are same, still we cannot say that 50 year is equal to 50 kg. That's why we will convert all the scale. That means we will convert all the units towards one unit. That means we may make by the using of z-score. You may convert this like this. All the unit is following like one condition. Like your formula may be, let's say you apply z-score and your data set will be like let's say it will be like 0.9, 0.8, 0.75, 0.95, 0.35, and 0.35, 0.85, 0.86, 0.98, 0.77. And this value, let's say, I am telling you hypothetically. Just give me 5 minutes more. I will explain all the things. Let's say this is 0.50, 0.61, 0.75, 0.81, 0.96. That means in this case we're converting all the value, like one is from like year, one is from like kg, and one is like from kilometer. We're converting all the value to one unit. That means in this case you may tell you that 0.9 is equal to similar to this 0.9. Let's say it is 0.90, then you may tell that it is nothing but it is similar. That means to convert all unit to one unit. That means that in previously you may see that there may be kg, there may be h, like year, there may be a kilometer. To convert all the unit to one unit, we will convert z score. Then why we are converting? There is a, in machine learning, there is a feature called standardization. There is a feature called normalization. In this case, we have to convert all the unit to one unit. That maybe our model will be going to work better. That's why we will convert all the value, all the units towards one unit. That's why we are using standard normal distribution. I may write it here. To take all the units to one unit. That's maybe years, kgs, kilometers to one common unit. We use z-score, convert standard normal distribution. It is very important in machine learning. In machine learning, the feature scaling, normalization, standardization, this concept come into the picture. When we will start coding and when we will start doing some things, and we will perform exploratory data analysis and analyze of the data. In that case, I will show you how our data will be standardized and how our data will be normalized, all the things. It will come into picture in standardization, normalization in machine learning. That means all the things you will learn, like Gaussian distribution or normal distribution. After that, we will learn standard normal distribution. There is also a concept like what is normalization. That is nothing but called as, that means to convert Gaussian distribution to standard normal distribution or normal distribution to standard normal distribution. We convert like with the help of z-score. That is nothing but called as standardization. Then you may ask me, what is normalization? In normalization, there may be a scale like I will give you example. In image, the image are divided into pixel. That means it is nothing but 256 pixel. In image, when we will convert like the ANN, CNN, that means in deep learning, when you will do some operation in deep learning, you first what you do? You just convert all the pixel between 0 to 1. That means to the formula, that means the definition will be data features value convert into 0 to 1. That means normalization means the value may be scale like 0 to 256 in the case of image classification, or in the case of image fixer. Just we convert all the image from 0 to 1. That means if you have like maybe 1 to 1000, you may convert into 0 to 1. That is nothing but called as the normalization. Normalization means you just reduce the size and you will convert into the size like from any range to 0 to 1. That is nothing but called as the normalization. Just ask me any doubt if you have any doubt from Gaussian distribution, normal distribution, and standard normal distribution. After that, we may start the log normal distribution. Any doubt from normal distribution or standard normal distribution, you may ask me. Or if I tell me, I will continue to next like log normal distribution.
Yes, sir, I can proceed.
Okay, no doubt. Okay, we will run like normal distribution and standard normal distribution. After that we will learn like log normal distribution. Okay. Number 3, nothing but log normal distribution. What is log normal distribution? You just I will tell you one thing. The distribution like this is nothing but when the like two sides is equally divided. This is nothing but called as the normal distribution or Gaussian distribution. But this type of graph like is nothing but called as log normal distribution. That means in this case you may see that it is equally divided towards left and towards right. But in this case you may see that when you go to x to y, first it is increased very much and after that it just slowly increase. That means when I will give you an example like let's say this is nothing but this is nothing but here comment length in YouTube. Let's say there is a video in that when you go to the comment section, what you will observe that there are a lot of people who just write the short comment. There's a few people like who are following like this who will write a long comment. This type of distribution is nothing but it is called around the log normal distribution. I will give you one more example. Let's say this is your distribution, this is nothing but your wealth. That means maximum people in this case, maximum people were like this is nothing but salaried people who are getting salary like the middle class people, and this class is nothing but it is like business class people. Then we may give you the example like let's say people write comment in YouTube. There is also example like let's say wealth distribution which I showed you here. Wealth distribution is following like log normal distribution. I will tell you, I will just clarify all the things here. This is nothing but called as normal distribution. In this case mu may be anything and standard deviation is anything. Just then there is your other distribution. This is called as standard normal distribution. It is also equally divided towards left and towards right. In this case mu will be 0 and standard deviation is 1. This is fixed. After that I will tell you one more thing. This is nothing but called as normal distribution where mu may be anything or standard deviation may be anything. After that there is also called a standard normal distribution. In this case mu is 0 and standard deviation is 1. After that there is other distribution. This is nothing but called as log normal distribution. In this case most of the following like towards left side, and in the when we go towards right side the decrease of the data will happens. This is nothing but called as log normal distribution. I just gave you 2 or 3 examples, which is like if people write comment in YouTube or in wealth distribution. This is falling under log normal distribution. Then you may ask me one more thing is that can we convert log normal distribution to standard normal distribution? The answer is yes. And how can we convert? I may show you one thing is that let's say We just convert. How we convert? Just we take a log of, when we take the data, when the log of data, then that is comes like this. You may see. I will show you on the, maybe in Wikipedia or on the Google. I will show you this thing. That means I'll write here. X is log normally distributed. Then ln of x has a normal distribution. That means when there is a, the value is false like the log normal distribution like this, and we can just take the log of this value, that value is like this, and we just take the log of the value and start to plot a graph, plot a distribution, that comes always normal distribution. Normal distribution. Just take the value, take the log of x, and after that what we got the distribution is nothing but the normal distribution. Now I may tell you one more thing, is that this entire process is called as feature transformation in machine learning. We just convert, that means we convert log normal distribution to normal distribution by taking log of x. That means suppose your x is like 5, 3, 2, 1, 7, 5, 8, 6. This is your data set, and this is for like this type of graph. That means the log normal distribution. When you take like ln of x, and whatever value is come, this always follows Gaussian distribution. It is nothing as normal distribution. This is nothing but as log normal distribution. That is the difference between all three distribution. One is normal distribution, second one is standard normal distribution, and third one is log normal distribution. In this three distribution, if anyone has any doubt, you may ask me. After that, we can go forward to covariance and Pearson correlation. I will explain all the things. In till this, if anyone has any doubt, just feel free to ask me. Just we completed normal distribution, we completed standard normal distribution, and we completed log normal distribution. These three parts are already completed. Just tell me if anyone has any doubt, or if not, then we can continue to covariance. Any doubt? If not, we can continue. Okay, no doubt.
No way.
Okay. We'll next we'll learn covariance. After that, Pearson correlation and Pearson's rank correlation coefficient. I will tell you the this hypothesis testing. We will learn next class. Now come to the covariance. Okay. Nothing but is covariance. Covariance. What is like covariance? Covariance. I will tell you the one example. Let's say covariance is highly required in feature selection. That means let's say there is a x feature, there is a y feature. Let's say I will tell you the x is 10 when x equal to 10, y equal to 15, x is equal to 11, y equal to 20. Let's say 11, 12, let's say 25. let's say 13, 30, 14, 35 and 15. Let's say this is 40. What type of relation you may observe in this x and y? From x and y, what type of relation you may observe? Anyone can tell me what type of relation we can observe from x and y? I will tell you. I will tell you one more thing. There are four type of relation may present. One is when x is equal to increasing, y is also increasing, x is equal to decreasing, y is also decreasing. This is number two. Number three may be when x increasing, y decreasing. Number four may be when x decreasing, y may also increasing. In this case, which type of relation we are finding out? Anyone can tell. Which
When
type of
x increasing, y also increasing.
okay, this is x is increasing, y also increasing. There may be possibility where when x equal to decreasing, y may also be decreasing. In this case, when you are x equal to 15, your y equal to 40. Let's say x is decreasing to 14, their y is also decreasing. That means these two are satisfying in this condition. Let's say in this case we can find out then how our x is related to y. That means it is positively correlative or negatively correlative. That means in this case we can find out that x is positively correlative. That means when we start drawing a graph, let's say this is nothing but 10, 11, 12, 13, 14, 15. Let's say this is nothing but 15, 20, 25, 30, 35. Let's say this is nothing but 40. We may this type of graph is coming. Let's say this is nothing but this is our data. This type of graph is coming. That is nothing but positive correlation. Positive correlative. That means in this case we are getting a positive covariance. Let's say in this case we are telling you that there is a 1, 2, 3, 4, 5, 6 features are present, 6 column or 6 row are present. In this case, by seeing the data, you tell me that the when x is increasing, y is also increasing. That's fine. When there are a lot of column are present, there may be a thousand of row are present. In that case, what you will do? There is a formula like covariance. In that by applying that formula you can say that that is positively correlative or negatively correlative. All the things you may tell me that. Let's say I will tell you the covariance formula. Covariance of x and y. This is nothing but summation of 1 to n xi minus x bar. This you have not to like memorize the formula, because Google is every time with you to search the formula. I just write it from Google, and so now I am telling you from that. Just understand the thing, how it is happening, what is the concept behind it, and you may ask as many time you want if you are not able to understand. Xi minus x bar, that's multiplied by yi minus y bar divided by n minus 1. That x bar is nothing but mean of x, y bar is nothing but mean of y. Okay. Thus I am giving you an example. By applying this formula, we will see that it is positively correlated or negatively correlated, and how it is dependent to each other. Let's say there is a feature called x, there is a feature called y. Let's say the value of x is 12, 13, 14, 15. Let's say y is 2, 3, 4, 5. By seeing the data, you can say that it is positively correlated. Okay, we will figure out is that positive or negative or positive by applying this formula. In this case, we may find out the mean of x is equal to nothing but 13.5. The mean of y is nothing but 3.5. Okay, then we just apply the formula covariance of xy. It is nothing but, you may see the formula here, xi minus x bar. That means first is 12, 12 minus 13.5 multiplied by 2 minus 3.5 y minus y bar. That means y is equal to 2 and y bar is something but 3.5. Similarly, when there is a summation, that means we have to add all the things plus 13 minus 13.5, 3 minus 3.5 plus 14 minus 13.5 multiplied by 4 minus 3.5 plus 15 minus 13.5 multiplied by 5 minus 3.5 divided by let's say n minus 1. Don't bother about this n minus 1. If upper limit is coming as positive, then it will be positive, or if upper is coming as negative, it will be negative. Just see here. Now when you calculate, let's say this is nothing but positive plus positive, because it is minus and it is minus, minus minus plus, plus this is minus and this is minus, minus minus plus, and plus 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 positive. It is nothing but the simple mathematics, plus positive. That means all the things is come under positive. That means you can see the when x is increasing, y is increasing. By seeing the data, we are telling that this is positive correlated, and by applying the formula, you are finding that the data is nothing but it is positively correlated. Let's say there is another example, x y x, let's say 5 4 3 2. Let's say it is nothing but 2 3 4 5. In this case, you will find that it is nothing but negatively correlated. When you apply I am not applying the formula covariance of x and y. You just apply the formula, and after applying the formula, you just find out that it is nothing but it is negatively correlated. In this case, what you run, like by seeing the data, by seeing the data, by having the data, you may figure out which type of relation it is established. That means when x is increasing, y is increasing, x is decreasing, y is also decreasing, or x is increasing, y is decreasing, or x decreasing, y increasing. In these four relation, you may find out which type of relation is we are getting. But there is a limit in this case. I will tell you one more thing, is that if covariance of x comma y comes 0, in this case, what we will do? Like in this case, when covariance is x and y is 0, that is nothing but our x column is similar to y column. That means if our x is 1 2 3 4 and y is 1 2 3 4, then our covariance of x comma y is nothing but 0. In this case, what we will do? We may remove one column. That means if one of the machine learning problem, if we have like 50 column, we have to just figure out, let's say in business perspective, or in any by the help of domain expert, we are not supposed to take all the 50 column to do some operation, because it is far difficult. It is very difficult to take all the data and all the columns to do some kind of operation, because it is very difficult. It is not possible practically. That's why what we will do, by the importance of the data, by taking the importance of data, which in this business problem statement, which data is most required, which column is most important, by taking the importance of the data, we just may collect 20 column, or maybe choose 15 column out of the 50 column. Then which basis we are going to like feature selection, that means which feature is going to we select. That means in that case, the covariance assessment in covariance come into the picture. That means when the covariance is greater, that features is we are going to consider. It is actually used when we are going to selection of the features. So we have to like sort some features according to our importance, By checking the importance, covariance is basically used. By seeing the data, we can see if our x is related to y, our x is not related to y. By seeing the data, we just consider we may consider some column which is most important to us. That is nothing but the covariance. Then second, we will learn the Pearson correlation coefficient. Before that, anyone has any doubt in the covariance, you may ask. As if anyone has any doubt. Like covariance is nothing. Covariance is actually used. Suppose I gave you the example. Let's say 50 column is present in a problem statement in a data set. In that 50 column, we have to choose like only 20 column. In that case, what we will do, we cannot by seeing the data, we cannot because there is a thousand of row. By seeing the data, we cannot say this column is important or that column is important. We cannot say. In that case, covariance come into the picture, and it will tell you that which column is most very important and which column importance is this percentage in this column importance is this percentage. By seeing the percentage, by seeing the result, you are going to select the data to build any model or build some solution with just by seeing the result of the variance. That's why in that case variance comes to the picture, and variance is used in that case. If anyone has any doubt, you can ask me related to variance. Studying variance, you may see one thing is that variance may be positive or variance may be negative, but there is no limit. Like variance is this positive may be 1000, this positive may be 7, this positive may be 7000 or something like, or this negative may be -7, this is maybe 500 or something like. But in this case, what we will do that there is no limit of positive or there is no limit of negative, and that's why we come to like Pearson correlation coefficient. In this case, in this Pearson correlation coefficient, the positive or negative, it should be under +1 to -1. That means, let's say our in covariance, one case x is related to y, like maybe +7, and x is related to z, maybe +8, maybe +1000. In that case, we are not supposed to say there is no limit. How x related to y is more important than x related to z. If I say there is a limited to 1 to -1, let's say I will tell you that x is related to y, let's say 0.8%, x is related to z, let's say 0.9%. In this case, you may tell me that x related to z is more important than x related to y. That's why to combine all the relation between -1 to 1, we come to the Pearson correlation coefficient. That means in covariance, the limit, there is no limit. That was the limitation of covariance. That's why we need to overcome the limitation. We need upper limit and lower limit. In this case, we come to Pearson correlation coefficient. I will tell you Pearson. Let's say this is nothing but Pearson correlation coefficient. The formula of Pearson correlation coefficient is nothing but rho of x comma y. The formula is, you may find from Google. I just did it from Google. You have not to memorize because every time, everywhere, Google is with you. Formula is very simple. Covariance of x comma y divided by standard deviation of x, standard deviation of y. When you calculate this formula, you will get always the ranges is come between -1 to +1. Let's take an example. X is nothing but 2, 3, 4, 5. Y is nothing but, let's say, 2, 4, 5, 6. In this case, you may find out x bar is nothing but 3.5, y bar is nothing but, that means mean of x data is nothing but 3.5, and mean of y bar is nothing but 4.25. Just in this case, I want to restrict our data, restrict our relation between -1 to +1. That's why I will apply what? Pearson correlation. When we apply this formula, covariance of x comma y, in the machine learning or in the Python, there is only just a line of code. When you write that code, you are able to get the knowledge. But before that, able to get the result. But before that, you have to understand how it is happening, what is the what is all the significant, or what is the beside beside the scene, what is going to happen. When after this formula, you will get your value maybe something like 0.8. I just take it the value from random because it will take a lot of time to calculate the covariance. After that, the standard deviation of x and standard deviation of y. But in Python or in machine learning, just a line of code. When you apply the code, after the data set, you will in the line of code, in the fraction of second, you will get the result, the Spearman correlation coefficient. In this case, what we get? Our value is restricted to -1 to +1, and let's say I'll tell you one thing is that this is an important point. More closer to 1 or -1, it is highly correlated. That means if I tell you that x and y are correlation is 0.75, x and z are correlation is 0.80. In this case, so I will ask you which is more correlated, then the answer should be 0.80. That means more closer to 1 or more closer to -1, it is highly correlated. I will show you an example. Let's say, just tell me, there is a case. Let's say this is our data set. In this case, our Spearman correlation is nothing but 1. That means all the data is following like in the straight line, is nothing but a Spearman correlation is 1. Suppose let's say this is our data. So all the data are following under this. In this case, Pearson correlation is nothing but -1. Let's I will take another example. Let's say this is our data. Something is following like this and something. But anyhow, when x is increasing, let's say this is x, this is nothing but y. But x is increasing, y is also increasing. But not all the lines, all the data points are falling inside the or on the line. That's why I may tell you that Pearson correlation is nothing but it is between 0 to 1. I will show you one thing. I'll show one thing. Spearman, not Spearman, this is Pearson. This is the Wikipedia page of the Pearson correlation. In this case, when you can see that. In this case, I am moving the mouse here. In this case, all the data set is falling on the line and it is negatively correlated. That means when our x is decreasing, our y is also decreasing. In this case, Pearson is nothing but this is -1. And in this case, when our x is increasing, our y is also when x is decreasing, our y is also decreasing. But not all the data points are on the line, and they are just closer to the line, and that's why this in this case the Pearson correlation is nothing but between 0 to -1. And in this case you can see when our x is increasing and y is also increasing, but not all the line are present inside the on the line. That's why the Pearson is nothing but 0 to 1. There may be any value. When you calculate, you will got the fixed value. In this case, when x is increasing, y is also increasing. In this case, the Pearson correlation is 1, and all the data are presenting on the top of the line. In this case, you can see there is no relation. When x is increasing, y may be decreasing. When x is increasing, y may be increasing or decreasing. That is not like not dependent upon the x. That means x and y is not correlated to each other. In this case, Pearson correlation is nothing but 0. You may see here you can see Pearson correlation is 1. Here you can see all the lines are not present. Pearson correlation is 4. Here you can see x is increasing, y is also increasing. I can show you. Pearson correlation is x is increasing, y is increasing, but all the line is not on the line. That's why Pearson correlation is 0.8. In this case, Pearson correlation is 0.4. In this case, there is no relation. In this case, the negative relation. In this case, more negative relation. In this case, more negative relation. You can see in this case. And you can see in this case, there is no relation of x and y. That is nothing but Pearson correlation. Other thing that come to now next part of you. Spearman rank correlation. In till this in Pearson or covariance, if anyone has any doubt, you just ask me or will learn Spearman's rank correlation. Correlation coefficient. Anyone has any doubt if in Pearson correlation, just ask me. In this case, just in the covariance, there is no limit. In this Pearson correlation, we want to restrict between -1 to +1, and the more closer to +1 or more closer to -1, there is more correlated, and less closer to -1 and less closer to +1, this is less correlated. That is nothing but the Pearson correlation coefficient. After that, there is other correlation coefficient, that is nothing but the Spearman rank correlation. Just ask me if anyone has any doubt in Pearson. If anyone has no doubt, then we can continue to Spearman rank correlation. We can continue.
Yes, sir.
Okay. Now come to Spearman rank correlation or coefficient. That is nothing but we just focus in this case. What we do? We focus in the rank. That means let's say I will give you it as a homework. You just search it on the Google or search it on the YouTube. You just learn yourself the Spearman rank correlation. That is nothing but we just focus on rank. Let's say x is 4, 3, 2, 1. Let's say this is nothing but 5, 7, 9, 1. We calculated the rank of x, rank of y. Rank of x and rank of y. That means which is 4 is bigger, then we will rank it 1. Then 3 is next bigger, then 2, and 3, then 4. In this y, which is bigger, we rank it 1. Let's say 9 is bigger, rank it 1. 7 is 2, number 3, then number 4. Now take this data to perform the Spearman rank correlation formula. That means by taking this data, we apply into the formula. The formula is very simple. Spearman rank correlation. It's nothing but covariance of x comma y, rank of standard deviation of x, rank of standard deviation of y. In the previous step, we just we just put it standard deviation of x and standard deviation of y. In the rank correlation, Spearman rank correlation, we will consider the rank of standard deviation of x and the rank of standard deviation of y. That means in previous the data is given to this like this. Just we convert the data according to the rank, and after converting the data, we just do all the things according to the converted data. We just apply the formula to this data. In this, after applying this, what will get the result in the Pearson correlation written here. Pearson correlation, we got the value from -1 to +1. But in Spearman correlation, we will get the value. Just a minute. But in the Pearson correlation, we get the value as +1 or we get the value as -1, either +1 or -1. I may show you the example here. Can you hear me?
Yes, sir.
Okay. Okay, in Pearson correlation, the value ranges from -1 to 1, but in Spearman correlation, the value is either -1 or +1. That means if your x is increasing and your y is increasing, in that case you will get value as 1. But it does not matter how many it is increasing. If it is increasing like 0.01%, still you will get the value as +1. If it is always satisfying the condition when x is increasing, y is also increasing, in this case you will get the value as 1, and when you get the value x is decreasing, y is decreasing, in that case you will get the value as -1. That is nothing but called the Spearman correlation. When that means in Pearson, the value ranges from -1 to 1, but in Spearman correlation, the value is either 1 or -1. That's when that means there is a very like that is nothing but the called the Spearman correlation. I can show you, but unfortunately there is a due to some error the system is not responding. We'll see in the next class. If anyone has any doubt, you can ask me, or we can continue in the next class. We may leave in the next class. We will learn the hypothesis testing.